Welcome back to Pentagram Prime, everybody. This is the Sun. About 35 trillion miles to the right, depending on your frame of reference, is Barnards Star. It's a red dwarf that moves across the night sky at a rate of approximately 10.34 arc seconds per year. According to Wikipedia, this works out to you wasting your entire life waiting for it to move roughly half of the angular width of the Moon. We know that Barnard Star is moving towards us because the light from it is blue shifted, corresponding to a radial speed of 67 miles per second towards the Sun. However, that's not all, because the movement across the night sky tells us that there is also a tangential component to the velocity. In order to calculate the tangential, we need first to consider the distance traveled over the course of a year. The problem reduces to that of an isosceles triangle, where we seek the length of the base, which we'll call d. We'll also refer to the angle that Barnard Star traces across the sky as theta. In case it wasn't obvious, the depiction of theta as shown here is not entirely accurate, and the angle in question is so small that it would be essentially microscopic if such a triangle were drawn accurately. This allows us to approximate the distance d as the angle theta times the radius r, since the value of the sine of theta actually approaches theta as theta becomes extremely small. Thus, we calculate d as 10.34 arc seconds times 35 trillion miles and get, oh yes, this trick only works for radian measure. So let us pause here to convert theta to radians. There are 3600 arc seconds in a degree and 180 degrees per pi radians, which gives us 5.013 times 10 to the minus 5 radians for theta. Plugging back into our calculation for d, we come up with approximately 1.755 billion miles traveled during the course of a year, in a direction tangential to that of the Sun. To calculate the tangential velocity, we now take the distance d and divide it by 1 year. A year is 3.154 times 10 to the 7 seconds per calendar year, according to Google. And we get this thing, which needs to be dumbed down to 2 significant digits because that's all we were given to work with in terms of the distance from the Sun to Barnard Star. And now that we have 2 orthogonal vectors, we can combine them via the Pythagorean theorem in order to get the space velocity relative to the Sun. My math worked out to 100 miles per second actual velocity. Wikipedia has about 143 kilometers per second for actual velocity. If we divide through by 0.62 miles per kilometer, we get something around 160 kilometers per second. Why does YouTube have to be hard? It just is. I guess that goes for anything worth doing. So, insert the revised figure of 87 miles per second for v, multiply times 0.62 like we did before, and voila, we now have something within 2 sig figs of a right answer. This problem came from the trigonometry text listed here, as well as the aforementioned Wikipedia article linked in the description. I'd like to take a moment to thank those of you who recently subscribed to my channel. And till next time, this is Pentagram Prime signing off.